Hi, I'm going to demo how to derive a cute little relation in Ursa. The relation that we're going to derive is going to be this. We're going to start with a over b equals c plus d over c minus d, and we're going to derive from that this. A plus b over a minus b equals c over d. So from that to that is what we're going to do. So when you load the Ursa page, the first thing that we're going to want to do is set the expression to what we want to work with. Expression.set is almost always the first rule that you use when you're using Ursa. It just sets the expression to what you put in. So now we're working with a over b equals c plus d over c minus d. So the first thing that we're going to want to do to work with this is sort of cross multiply, bring the b over to the right-hand side and the c minus d over to the left-hand side, so we can multiply both sides of an equality with the rule called equality.multiply. It multiplies both sides of an equality by whatever you put in. So we're going to multiply by b, and then multiply by c minus d. And then we can use the simplify rule to simplify this and cancel all the terms. The next thing that we're going to want to do is distribute both sides of this equation. And there's a rule called distribute, which I'll just show on its own quickly. A times 1 plus 2 plus 3. If I set the equation to this and then say distribute, it distributes the multiplication over the addition, so we get a times 1 plus a times 2 times, or plus a times 3. So we can run that back here. We can run that recursively on every sub-expression by using the bottom-up rule. Bottom-up takes a rule, which I'm going to put in distribute, and runs that bottom-up on every sub-expression. So now we have a times c equals a times negative d, equals c times b plus d times b. So that's what we've got now. And the next thing, there's a little detail here. The second term here, a times negative d, it would be nice if we had a times c minus a times d instead of this. And we can fix that using another rule, which I'll demonstrate really quickly on its own. A times negative b. If we have a times negative b, we can bring the negative out using a rule called commute. It's in composition.commute, and it commutes two functions, f and g, that can be swapped. So if I say commute neg, as you can see here, we have times a with neg of b is this expression in sort of flat expression tree form. So we want to pull the neg out. So if I run composition.commute neg, it pulls the neg out, commutes the neg with the times. So now getting back to our expression, we can run that bottom up too. Bottom up commute neg. Now we have a times c minus a times d. Now we have the a's collected on the left-hand side and the b's collected on the right-hand side. And since we're trying to swap the roles of a and b with the roles of c and d, it might be a good idea to collect the c's on one side and the d's on the other side and see where we get. So let's add AD to both sides and subtract CB to both sides to move the C to the left-hand side and the D's to the right-hand side. So we can say add A times D and subtract C times B and then simplify. Simplify. And now the C's are collected on the left-hand side and the D's are collected on the right-hand side. Now, the next thing that we want to do is observe that when we just before we recollected our terms, what we did was distribute. So now maybe we should factor. Maybe we should factor out the C on the left-hand side and factor out the D on the right-hand side. Now, factor, I can say bottom up, factor C, but you'll see this will look a little weird, and I'll explain why. So what we get is C times A times 1 minus 1 times B, and we can simplify that away. But the reason that that looks like that is that if you have something like A times, or let's say A plus a times b. And let's say we want to factor a out of this. This a on the left will become a 1. We get a times 1 plus b. And the logic that gets this right also makes it so if you try to run factor bottom up, you get those weird ones. And I would like to fix this, but that's the way it is right now. So we can either factor and then simplify, or we can use this in rule to go into the left-hand side. So now we just have this selected, and then we can run factor C directly on this, not bottom up on every subterm. And that works correctly too. So we can factor out D from the right-hand side. Now we have C times A minus B equals D times B plus A. And now we're almost there. We just need to divide both sides by D and divide both sides by A minus B. So let's do that. Divide both sides by D and divide both sides by A minus B. And then simplify. Now we have C over D equals B plus A over A minus B. And that's morally the right thing, but let's clean it up a little bit and make it look right. We can go in and then move right and then go in again. And there's a rule called swap that swaps two arguments of a commutative operator. We can run that on the equality too. And now we have A plus B over A minus B equals C over D. So we're done. And just as a bonus, just for fun, let's run swap bottom up. Bottom up swap. So this will swap every pair of terms of commutative operators throughout the whole expression tree. If we do this, this is what we get. I'll undo and redo so that you can compare. We started with A plus B over A minus B equals C over D. And when we ran swap bottom up, we got 1 over DC equals 1 over minus B plus A times B plus A. So that basically swapped every pair of sub-expressions. So we don't actually want to do that. Let's leave it like this. So there we go. That's all.